You ready? Okay, so when we've got these things, last time we did area under a curve and we approximated by like making little rectangles and trapezoids everywhere. This time we're going to find exact area under a curve. We're going to start with definite integrals and shapes that we can calculate the area very easily with. So special note is when you're doing a definite integral, you're going to have things that are positive area if they're above the x-axis, but if you draw a rectangle below the x-axis, then the y value is negative, right? And so if you multiply a negative y value times the base, you're going to get negative area. So anything that's below the x-axis will count as negative area. And so when you add up all the areas from below and above the x-axis, you're going to get what's called net area. So like total accumulated area, like adding the area that's up top and taking away the area that's below. Okay, so that's what the definite integral is going to get you. Now this is the notation for definite integral. This is your integral sign. A and B are the bounds of your integral, and this is your function. And the delta x is just the width, right, of each rectangle. But the width of each rectangle is gonna get really small, right? Just like the area. Okay, so when you read this, this is the definite integral from a to b of f of x with respect to x. Okay, so the dx kind of tells you what you're taking the derivative with respect to. Okay, 5 different parts. This part down here is your lower bound. So you're always going to start with this number down here, and then you'll go until you hit this number. That's your upper bound. Okay? This symbol right here is your integral. So that means that you're finding area under the curve. This is your integrand. It's kind of like the radicand when you're doing the root functions or whatever. This down here is, the whole thing is called the definite integral. And the dx, this is your variable of integration. So we're going to take the derivative with respect to x. Sometimes you do other variables, and then when you get into multivariable, then you'll have multiple variables of integration. Yeah, and you'll have like double and triple integrals. But not right now. Right now, we'll just do one. So the definite integral can be used to determine net area bounded by the function and the x-axis. So when we're talking about definite integral, it's bounded by the top is the function and the bottom is the x-axis. If it's below the curve, the top is the x-axis and the bottom is the function. All right, we're going to evaluate some definite integrals, but evaluating them we're going to do with lines and shapes that are easy to calculate the area of. So before we start, I'm going to go ahead and calculate the area from the function to the x-axis of each little piece. Sometimes that helps first before we start. So the area of this is 2 times 4. 8 divided by 2 is 4. This is a semicircle. radius 1, 2, 3. So pi r squared over 2. 9 pi over 2. Do you want to do a trapezoid or a triangles and rectangles?
Trapezoid.
Okay.
Triangle.
Well, it's Andy's birthday, so we'll do triangles. So that's 4. And that's 4. That's 12. Okay.
What's that?
20. Are you just joking? This little thing is 1. And what is that? 3. So 3 over 2. And then here is 2, 3. And 2 times 3 divided by 2 is 3. Okay, cool. Now we've calculated all the little areas from the function to the x-axis. And so we want the definite integral from 0 to 7. So we go 0 and add up all the areas up until we get to 7, and that equals 20. Nice. Easy? 0 to 13. So we add up all of the area up to 7, then we start going underneath the x-axis. We need to take that area away. So 20 minus 13.5.
Yes.
So 6.5. Okay. Cool. We're going area from -6 to 0. So from -6 to 0 would be -9 pi over 2. Because it's underneath the x-axis, so the net area will be negative. What's the integral from 3 to 3?
Yes. 4.
Yes,
0.
is the answer. 0 is the answer. You have accumulated no area if you're integrating from 3 to 3, right? So no area is accumulated, so your integral is 0. 7 to 0 this time. So we're going from 7 backwards to 0. What do you think I should do?
Negative 10.
Yeah, it's -20. Good thought. So it's the opposite of, if it's positive, when you go from 0 to 7, when you go from 7 to 0, you make it negative. And if it's negative from the start, then you make it positive. All right. I think you're ready to do 6 through 12 on your own. I'm leaving you. I'm taking the training wheels off. No, you don't.
Oh my god.
It's 10 to 4.
Six. 15 over 2 minus 10. 25 over 2. So negative 25 over 2. Oh yeah, that's 2. Nani? Yeah, it's because it's backwards. So like
10.5 minus 9.
oh, it's here.
Just leave it. Leave it unsimplified like that.
I just got. Nani? No, okay. So. Six. So 6 plus 3 over 2 is 15 over 2. 15 over 2 minus 1 over 2.
We 10 to 4, so we're going to so this is the positive, this is negative.
Yeah.
Yeah, this is like positive 7.5.
Yeah, so 15 over 2.
And then this is
40 over 2.
This is like negative.
Yeah, negative 40 over 2.
Negative what?
40 over 2.
40?
It's kind of insane.
No, I'm not. I'm just kidding.
40?
6.
That's negative 8.
Yeah.
Plus 7.5. So it's negative. Because it's yours. Yeah, it's my birthday. You're fine.
What has old age done to you, Andy?
Andy, why are you so old?
24.
He's older, but he's younger.
21.
No, he's older.
12.
I'm actually 14.
21 over 2. 21 over 2. Minus.
You don't look like you're 14.
Yeah, no, I'm taking personal.
I got this. Yeah. Wait,
It's all those genetically enhanced fruits that he's eating.
Okay.
It's a negative.
False.
Yeah.
Grape juice with calcium in it.
Calcium, you don't make
It's
it
for
really strong. And then vitamin C.
Did it sound like purple?
Grape juice. Grape juice. Yeah.
That's how I knew it was October 1st.
I've been on Reddit today. That's about it. So on a daily basis.
No, I think it's continuous.
If you like, said you need to be in front
Because there's 10 over here to the negative 6 over here.
Are you guys
I think
doing
it's because there's negative 6.
Yeah.
Like, is it discontinued or is it just like covered by negative 6?
Why did you choose to use this?
What do you think?
It's covered by negative 6.
You're going to be talking about.
Does that mean that the derivative exists?
I'm going to write.
Some slip. This is
Yeah, I think it's like negative 6 over here.
pretty sure.
Okay, this is not what's average rate of change?
It's not a shark.
Average rate of change is secant slope.
No, because like you see here, something happens.
Oh yeah, so if it's not continuous, it can't be
One
differentiated.
higher than that.
So it doesn't.
Oh, yeah.
No.
Wait, what are you talking
I don't know.
It's like there's a number here.
Okay, well, yeah, but it's not that.
That was like
It's
pre-calc.
like a graphic.
No, that was like algebra 1.
That's it.
You learned slope in algebra 1.
Yeah, but average, that's pretty complex.
Are you sure it's
Yeah, you guys just didn't like calling it average rate of change in algebra 1.
because the slope isn't changing.
No.
It says positive 6.
That would do.
Could be D&D. Slope.
What do you think, guys?
At 6.
Oh,
think it is.
Good. You have a quiz coming up soon. Next Friday. Next Friday.
Like this Friday or next week?
No, next Friday.
Based on our performance on
But that's the like, I'll see you this Friday and then I won't see you for a week. Yeah, yeah. That's what we call a later problem.
It's like if you pick up, our test started out as really hard, and then it got exponentially easier by the time it
It's so high.
Is that like what's going on?
Are you gonna actually do the PSAT?
Don't think so.
Okay.
I think the level of difficulty will remain the same.
Oh, that's actually still not gonna be with that. These tests haven't been taken. That's
Good.
one of those. It's been one is waiting for it.
It's 4 plus
Relax.
positive.
Me? Maybe. Or I'll get angrier and angrier and angrier.
But use funny answers.
Andrew Jones.
Yeah.
Yeah.
What are you doing for your birthday?
Yeah, what are you doing at school today?
writing essay.
Oh, nice.
Oh,
You should come to the Sad Patriots meeting.
Yeah, that's where it's at.
Yo, sometimes I like to
Are you
just
inside
sit
of
down and
Patriots?
write out the names.
Okay, that's okay. You said all people.
I'm like, oh,
We're just sitting around not really doing it.
how was the ball?
It's not bad.
Right.
Dude, I was about to stay up until
Incorrect. You're dealing leaders are doing something.
Eric.
All the windows.
Other people did.
John said he has something for
Why is
that.
number 9 0?
Because it's asking for the second derivative at 6. And so at 6, what's the concavity?
What's his fault?
down.
Nothing.
John, just think that today.
Yeah, it isn't. It's just a straight line, right?
No, it's important. You need to have an account.
So there is no concavity, so it's 0.
I'm gonna get my laptop today.
It's 0 because the first derivative is a constant -2, and then the second derivative would be 0. Also, because if you drew a tangent line, it lies directly on the curve, on the graph, and so there's no concavity or 0 concavity when it lies exactly on it. Okay, are we okay with 8? Do we know why?
Because it's discontinuous.
No, it's continuous. Yeah, you can either say two things. You can say sharp corner or cusp, or like here at the, what is this, a semicircle, there's a vertical tangent line here.
I call it a pointy board.
A pointy boy? Yeah. As long as you spell like boy, B-O-I.
Yeah.
Yeah. Then it's okay.
I'll keep that in mind.
Yeah.
I will.
It's a pointy boy. Yeah. Yeah, that's what I was going to ask you. Do you think it's differentiable at -8 and 13?
No.
Yes. Yes.
Because my one class said no, and then the other class said yes. I think I would go with, you're right, it's not differentiable at -8 and 13. Because technically, there is no derivative on the other side, right?
Well, if you wrote 13, you have to.
Yeah.
If you really want to know.
Come on.
And then, oh, for 10 I didn't finish it. Did you get 4/5? And then 11 I said true, because if you take the area from 0 to 2 and add the area from 2 to 4, you'll get the area from 0 to 4. That's just common sense.
Whoa.
Well, calculus common sense. Right?
Team B, right?
Okay. All right. Now what?
Isn't it Team B?
Properties. So, we've gone over a lot of these by doing the first page. But if you think about it, these are certain properties. The integral from a to a is going to be 0 because you've got no area, right? We talked about this too. The integral from b to a is the same thing as the integral from a to b, but made negative. So if you don't like the order, you can always switch the order of your lower bound and upper bound as long as you change the sign. This was one of the last ones. The integral from a to b of f of x, you can split it up into 2 parts. So you can go a to c and then c to b. Interesting, right? What? A good reason why you would want to split it up is if you have a discontinuity in the middle, you would want to split it so that you could still find the area. Good question. Other properties of definite integrals, these are the same as derivatives. Like if you have a constant, it's always best to move the constant outside of the integral because it just makes it easier. Over addition and subtraction, you can distribute the integral across addition and subtraction. So you can integrate f of x and then integrate g of x and then add the two together. And then this one, if you just have a constant k, then it's just the graph of like a straight line. So if I want to find the area from A to B, it's just a rectangle. So it will be the height k times the base b minus a. So that's how you integrate a constant. It's just k times the width of the interval. All right? So these three properties we will use to answer questions where they give you part of the integral and you have to figure out things being done to it. So what's the integral from b to a of g of x?
So they should be cosine.
Let's see.
3.
Yes, because a to b of g of x is -3, so b to a would be +3. For part b, remember 2 can come outside of the integral. So if you integrate, you already know the integral from a to b of f of x, that's 8, so 8 times 2 is 16. All right, c is a constant, so I just do what? Thanks. D is a constant and g of x, so I'll split this up into 2. The dx gets distributed as well. So we already know that. We did that one already. That's 5 times b minus a. And then the integral from a to b of g of x is -3, so just -3. Can I distribute across subtraction?
Yeah.
Yes. So this is integral a to b of f of x dx minus integral from a to b of h of x dx. So that is 8 and h of x is 5/2. And f. Yes. Because we integrated from a to 4 and then 4 to b, so it's the same thing as the integral from a to b of h of x. Okay. Not bad, right? All right. Now, you try this one. They're telling you that the integral of this whole thing is 34. See if you can isolate the integral from 1 to 5 of f of x. Don't forget these 3 properties here. So you might want to split the integrals up, evaluate each part, simplify, and then go. Oh.
Interesting.
Interesting. Very cool. do you think? Simple, what do you think?
Thinking about,
You don't have the power to think. Eric? Me too!
this was like kind of,
Nice job. Oh, well, you did a lot more than I did, maybe? Or you did a lot less than I did.
for mine it was only like 2 steps.
I got the right answer.
What? I mean, fine. Do whatever you want, but if you got 6, then you got it right.
Yeah, if you don't write all of that on the test, you get no justification.
On free response.
No, multiple choice too.
Multiple choice. Hey, give me an example of an even function.
Y equals x squared.
All right, well,
We were about to give like a
that's not a very interesting one,
Okay,
but
let's
okay,
just say
fine.
that x equal interest.
That's a straight.
Hey, so if you know the area from 0 to 3 is 8, even functions are symmetric over the y-axis. So what's the integral from -3 to 3?
8.
What?
16.
16. So even functions,
8 plus 8.
you double the amount if it's symmetric over the y-axis. What do you think odd function's going to do?
0.
Yeah, because odd functions, give me an example of an odd function.
X cubed or X.
X to the 74.
Oh.
Okay, I don't know how to draw x to the 70 first.
Yeah.
Let's just do y equals x. So area from 0 to 3 is 8. The area from -3 to 3, this is a -8, would be 0. So odd functions over the origin, and you're going the same distance both ways, will go to 0. Even functions will double.
Is Y equal 1?
Y equals 1 is neither even. No, it is even.
So that's
Yeah. Y equals x plus 1 is neither even or odd. Okay, let's do 2 different ways here. Example 5. Sketch the region defined by the definite integral. Then evaluate each using a geometric formula. Okay, so we gotta draw some pictures. X plus 3.
that's a line.
Are you gonna make us draw pictures of the test?
Well, maybe.
Does he not draw lines?
Then, I'm gonna,
What are you gonna do?
Just not draw the line.
I'm still there.
Oh, it's been so long since I've done
Okay, we need the area of this region.
some complex graphs. Split it into a triangle.
Okay, fine. Well, the area of this then is.
12.
Didn't you say triangles before? Why are you going trapezoid now?
It's 9.
Because I said it before, so you're doing it different.
Because the height is 4.
Yeah, the height is 4, width is 3.
It starts at 1.
Okay, so this height, this right here is up to 4. What's this?
3.
Yeah, to get to 7,
So
right?
That's 6. 3.
What?
6.
Actually, 9 over 2.
It's some number though. It should be.
Oh my gosh, we gotta go back to geometry.
Yes, really my favorite class.
Geometry?
Fake it till you make it.
Yeah.
What does that equal? 12 plus 9 over 2, 9 over 2. 33 over 2.
I created my own.
Okay.
I call it the link language.
Okay, cool. Not too bad. Hey, here's another way. Let me show you this
You
one.
don't seem to be playing anything right now.
Oh.
Hey Siri.
You should disable Siri. It's a security.
Hey Siri.
It's not gonna. Eric, your voice sounds nothing like
It
mine.
worked.
Hey,
It
Siri.
worked, though.
It did.
Hey Siri, what's
No.
my address?
It doesn't work.
It worked on my English teacher.
Really?
No, that's
This
it.
is something you do with your teacher.
Okay, I'm gonna split this integral up. This one is 4 times 3 plus 1. And then this one is y equals x. So 3, negative 1. So this area is 1/2, yeah. And this area is 3 times 3 divided by 2.
2.
So, oh, this is a negative 1/2 plus 9 over 2.
So 4.
Yeah.
Alright.
So we got 16 minus 4, so 12. Which way do you like better? Drawing this one or drawing the little one?
First
Split.
one.
I like the first one.
I like the second one too, but whatever. You can do it whatever way you want to do.
For second one, you kind of did one more extra.
Oh, she's
I like both of them. Okay,
Oh.
next one. How do I graph this? Let's see if you guys remember.
Let's just try it on our.
No, you don't do chain rule. We're not even deriving.
You square.
Okay, not yet. But you can't even do u sub though. There's no x on the outside.
You square the entire base.
What's use?
You'll learn u sub on next Friday. Eric, I like thoughts. John.
You square the entire equation.
What? Why? You can't just throw a square in there. I don't like that thought.
If you square it.
Guys, you don't even know.
Really? You haven't learned it yet.
Yeah, sure.
You should know. What's that an equation of?
Oh, it's a semicircle.
The cheese test.
So if I solve for y, then I get plus or minus square root 4 minus x squared. So what is
I was
this?
right,
So
you
the
square
top
it,
part.
and then you get this circle.
Oh my god.
Yay.
Top part
Square in the-
of a circle. You don't just throw a square in.
Good though. And then square root your answer.
No.
That's how math works.
Mhm.
That's true, John.
See, I have sun.
But if you square it, then you're getting more than one answer.
2 pi.
So you divide your answer. by
Yes,
2.
good job, Andy.
Yay.
So we're finding area under the curve from negative 2 to 2. So it's 1/2 times pi. R is 2 squared, and you get 2 pi. Okay. Now, guess what?
We're trying to
Yes, you're going to do the rest on your own.
Oh.
What do you mean,
It's
oh?
better that way.
Yeah, do D, E, F, G, H.
So stop it.
Then we're almost done.
Or like
We just have to do anti-derivatives.
Isn't it derivative? Isn't it derivative?
I mean, not really.
Not me.
Andy might have some NDCS passwords.
No, guys, that's illegal.
So is jaywalking.
So is vaping in the bathroom.
Wait, what?
What's the vape?
I jaywalk all the time. I'm not gonna lie. There's this. I know. There's this intersection, and it's so annoying to wait for the.
Someone jaywalked across the intersection like in the back of Madison, you know, where the 4 roads come together.
Yeah.
I was like, what are you doing?
Do they walk diagonally?
Yes.
That's when you
All
know.
of the cars.
Yeah. That's when you know you're like professional jaywalker.
Interesting.
So I was trying to turn right, and then he starts walking. Like, oh, he's going the other way. Just diagonally
It's like
across.
when people say you can take science out of school.
Hey, just gotta get somewhere. Just gotta get there fast.
Go fast. Like,
Gotta go
I'm not
fast.
listening fast.
All right, guys, finish these. Oh, yes, it's working now. It's wonderful. Our AC was broken during fourth period. Or was it fourth? Yeah, fourth period. Well, it's now nice.
Who's ready for the text in 10 minutes?
Oh yeah. So you you have to finish
Before
the 5 of these before the text comes.
What
The
text?
text.
The emergency text.
Why?
Yeah.
They're testing some alert on all phones.
Why am I so
Dude, once the F-word glitched on my phone and it sent it to me, like it wouldn't go through, but I just
It said the integral was just
characters and it sent it over like 2,000
Yes.
digits in one night.
So it's the top part.
After that, I just enabled F-word. I'm sorry.
That's why I'm not very
Please
Disable fearless.
Okay, sure.
Dude, it just it wouldn't stop sending it.
Okay, I got 4 hurricane
semicircle.
alerts in the middle of July.
What was that?
So you
It would,
do.
if
So
it was
you.
negative.
Wait,
then it's the text. That makes more sense.
I'm so confused.
I see.
Which is. Oh, you have to complete this.
Oh, we should draw this real quick. Yeah.
Is it negative 3 plus 9 pi over 4? I'm sure that I got wrong.
Yeah,
I'm sure I got wrong.
Not negative.
Positive 3?
You separate.
Oh.
You just need this.
Oh, yeah.
Okay, that's not bad. So radius.
Because, you know. Oh, I.
I like splitting.
1/4, right?
Yeah, because if you draw, you kind of get messy.
Yeah.
So it's.
Oh. It's clever, actually. I mean, not really. But kind of.
Small you went towards the cyber patriots meeting today.
No.
Cyber what?
What? Why? Yeah. What is this? What is the
Cyber
meaning of the name?
That's where we go and learn how to do stuff like I did too.
That doesn't. That seems very unpatriotic to me.
And we learn how to stop that, sorry,
Oh, okay.
by learning how to do it.
Is that a meaning?
Yeah, there is a meaning behind it.
When?
So you learn how to
So you learn how to become a white hacker.
stop
Oh, what? You learn how to be
stealing
anti-hacker.
So it's
by
white hacker.
stealing.
Yeah.
Plus 3. Wait, why you guys add 8?
I think you can get a lot of information from
Plus
security
18. 28.
after
Wait,
class.
how
I'll see how much I can get about it.
No, you will not.
You only go from 0.
Well, if you don't give me your password, therefore I should get no information.
Oh.
Each. I have 5 minutes, 7, 8 minutes left.
Yeah, better get to work.
So 9 pi over 4 plus 3? Yeah.
What all kinds of work down here.
I only have 5 minutes left.
Is that the French fly or
7
is that the other way?
No, it's at 2:18. Beginning at 2:18. We're at 30-minute period.
Alright, so we got about 3 16 just
Although considering how close we are to BC, I wouldn't.
I already did, but like, it's so loud. It's really loud.
Oh, what is that one?
Yeah.
I love zero. This one's zero. Is that odd?
It's an odd function in this name.
Yeah. It's like it's just sideways. Hey.
Whoa.
What do you think?
Interesting. H is actually lots of learning.
Because it's odd.
Oh,
This is odd, yeah.
this one.
So if it's odd, it cancels out. The balance of
Wait, if I
yeah,
plug
for that one I did. But
John,
it's the same thing.
if I plug my earbuds in, will it still ring? Unless I just speak up. Or is it just ringing through my earbuds?
I think it'll be I don't know, test it out.
Yeah.
I'm gonna turn my volume all the way up and then turn my ringer off.
Basically, cool. And
In preparation for this all powerful test.
although it's great because both people like just they
I
sit
don't
every
put the
single
meter
day.
volume down.
I would see him in the mornings, just like in the halls, like hey, what's up? Like at like 8:15, 8:20. Mr. Thompson, I showed up late. It was like I was like the Christian Association.
Wait, is the aim for wait, this was your thing, right?
Yeah.
Wait, is the area is here?
3 plus 12.
It's a multi-level.
Yeah.
Well, I want 5 minutes. So,
2 pi.
Family is bad. Like I said, I thought it was because Christian's been going to school every day for the past
Minus 6.
few years. And his dad found out apparently he was doing that. Like that just denied to give him a ride to the so he had to figure out how to get to school. And he said he walked one day. I don't know actually. Maybe he did it. Maybe he
Yeah, I know. I just had never heard about it.
Maybe his teacher did it.
I didn't know when it
That's
was.
true. To a certain like time, some teachers.
I got 2 pi plus.
Because me and me and it was before 8:20. And I never actually tried showing up later than that.
My horse never
Like,
stopped.
I think she probably would have pushed it a little. Like,
Okay.
oh, I agree.
Ready, alarm.
Yeah, but I'm going to start putting up some of the answers.
Alright, I turned on my ringer and I turned it off.
Okay, I'm gonna
Okay.
put my earbuds in.
Think about it. I don't think I know.
Did you get 3 plus 9 pi over 4?
Whoa.
Yeah.
No?
Yeah.
This is a test of the National Wireless Emergency Alert System.
Air.
Presidential alert.
Presidential
I'm the
alert.
president.
Dude,
That's not what it means.
Nope.
What does that mean?
It's alerting the president. What does this mean?
Oh, I got it.
You have it?
It's quiet though.
Depressed.
Mine doesn't make any noise.
Yeah.
Yeah.
You kind of
Yeah.
I'm depressed.
Well, somebody's
No
it's
action.
gonna make.
Oh, I'm gonna say that the ballistic missile.
What if action was needed? That was what I did.
Then it would say action needed. I don't know. Do you remember that like bomb threat that was in like Hawaii
Oh yeah.
last year?
Oh yeah.
My friend was visiting Hawaii at the time, and then they like got the alert on their phone, and they're like, "Oh my gosh, what do I do?"
I don't even know if I'd freak out. I would just accept my fate.
Yeah.
There's nothing you can do. You're on an island that you can't get off of, and there's nothing you can do.
And then nuclear.
Okay, did you check E and F? F is an odd function, so you should have gotten 0, yeah? Cool. And then G and H.
Yes.
It's good? Yeah? Easy? Any questions? Anybody? 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 All good? All right, cool. Now, let's talk about antiderivatives. Yeah, those are antiderivatives. Antiderivatives. Okay, yeah. So we go capital F now to anti-derive little f, like a lowercase f.
Where do you go after the uppercase S?
Like bold, maybe? I don't know. It's already italicized. All math is italicized. I don't know.
Did they write with italicized?
But, so an antiderivative is like basically doing the opposite of a derivative. The family of all antiderivatives is called the indefinite integral. Okay? So think about this. If I have a function f of x equals 2x, give me a original function where the derivative is 2x. Good. X squared, right? Okay, but
Plus C.
yeah,
91.
X squared equals 9 million.
Yes.
yeah, you can add any number to it, and the derivative would be
Something very, very
2x, right? Every single time.
But all you have to do is find your starting velocity.
Right, any one of these have a derivative that equals 2x, right? So if we want to identify like the family of functions that the derivative equals 2x, then we add on like a constant c. Sometimes we can find it if we're given enough information, sometimes we can't. But we only have to add on the plus c for indefinite integrals. You do not have to add them on for definite integrals because the c ends up canceling out for definite integrals, so you don't have to worry about it. But for indefinite integrals, you need the whole family of functions that it could possibly be. So, what?
What if you have to integrate the C's?
Yeah, you might have to. And if you do, then they're going to give you more information. Yeah, good question.
Integrate the C.
So here's the general antiderivative formula. The plus c is the constant. It's called the constant of integration.
Integrate.
Okay, and this dx is still your variable of integration.
Yes.
Not always. Actually, yeah.
Yeah. Yeah, it just tells you like, it basically tells you how much up or down to shift the graph, the original graph. Yeah.
Yeah.
I can tell if you just really wanted to know.
Okay, these are the rules we already talked about. Shh, guys. The constants can go out in the front. You can distribute integrals across addition and subtraction. You can't do it across multiplication and division, because we have product rule and quotient rule for derivatives, so we'll have something similar for integration. And then let's go over general power rule. Now when you're taking the derivative, you take the exponent, bring it down in front, and then you subtract the exponent by 1. Well, for integration, you're going to do the opposite. So you're going to take the exponent, add 1 to the exponent, and instead of multiplying by your exponent, you divide by your new exponent. So don't bring down first, increase the exponent by 1, and then divide by your new exponent. Okay? Let's go antiderivatives of each of the following. So capital F of x. 8x plus c. Right. We want the whole. We need the whole set. Yeah. G of x equals 3x. Is capital G of x equals? So we add 1 to the exponent, so we make it 3x squared, and divide by my new exponent over 2 plus c. Capital F of t equals
t cubed over 3.
Yeah, t cubed over 3, or you can say 1/3 t cubed plus c, whatever you want to. E square root of t, that's like t to the 1/2. So capital G of t, the antiderivative, will equal add 1 to the exponent first, 3 over 2, and then divide by your new exponent. So when you divide by 3 over 2, you can multiply by 2/3. Just flip it. Plus c, right? All right, F, take a look at this. If this is t to the -1, then what happens when I add 1 to the exponent? It becomes t to the 0. Then I divide by 0, which I can't do, right? So there's a special integral for 1 over t that some of you might already know, but we'll learn later. Yeah, it ends up being natural log, but we're not going to do that now. I just wanted to show you that power rule doesn't work. No. Okay, G. This one still works. So anything to the power of a negative exponent other than 1, you can still integrate. So this is t to the -2. Capital R of t equals t to the divided by -1, so we might as well just put a negative out in front, plus c. H capital F of x equals
-2
x to the -2 divided by -2, or you can say -1/2 in front if you want, plus c. Okay? All right, do J and I and see if you get the same answers as me. Because I didn't want to, I had just grabbed the whole table and I didn't want to rewrite every formula, so I figured it was easier to put x's.
Are we going to come back?
Probably.
That's true.
I wrote S of t for this one because when you integrate velocity, you go back to position, right? But you could have written capital V if you want to.
What's that? Distance?
Position.
Oh, I don't know.
sometimes they use x as well.
What's that?
Integrating displacement. You're finding like total distance traveled. I don't know why you would define it. Okay, a couple of properties that we should talk about when you have something like this. Right now, I haven't taught you USub, so you don't know how to integrate this, but you can always multiply this out and then integrate it a lot easier. So that would be 3x cubed minus what? Yeah, 3x squared plus x plus c, right? And then for this one right here, remember you can always, there's a single term in the denominator, so you can always distribute it to each term in the numerator. So this could be x to the negative 3. This could be plus 4x to the negative 4. And this is 5x to the negative 5. And then integrating that is a lot easier because we don't have like a opposite quotient rule method for integration.
There's no way to do quotient rule.
No, you have to turn quotient rule into product rule and then do opposite product rule, which you guys learned this year, but AB doesn't. Inverse product rule is called integration by parts. So we'll do that this year, but not yet. So the integral of this is
Negative 1/2
the integral of this is
4 over 3. Negative 4 over 3x.
x to the negative 3, yeah.
Minus 5 over 4 x to the
Negative 4 plus c. Nice. Okay, cool.
No? Yeah.
All right. So, if they give you an initial condition or some condition, then you will be able to solve for C, because then they're going to give you a point on the curve, and so then you can know how high or how low to put the curve so that it will go through that point, right? So if they give you that the derivative is 2x minus 1, and that the original function hits 5 at 2, when you take the antiderivative of this and you get x squared minus x plus c, you can use your initial condition to solve for that c value. So 5 equals 2 squared minus 2 plus c.
3.
So now your original function is one singular one. It's not like a family of functions. It's x squared minus x plus 3, right? Okay, we're going to skip B, but I want you to try C or D. I'm going to write down the answers so that you know, and then we're done for the day. And your homework is on Delta Math.
Yay.
Yeah, good.
I like Delta Math.
Okay, good.
Yeah, it's pretty convenient not having to go get my backpack to do my homework.
I mean, it sucks that I have to do my homework in general.
Well, you just like write it down on a random piece of paper, yeah.
Or
And then it's submitted
one time,
and
like,
it's
I
done,
copied
right?
it incorrectly,
And you got
I should've
wrong,
paid for
and did it
It's
again.
like this long problem, and I just got the whole thing wrong.
I put 2 parentheses around something like that, and then it was like, no, we can't have 2 parentheses, that's the wrong answer.
And also, like in some problems they want you to simplify all the way, and some they don't, but they don't tell you which ones they do. Like on the room on some, I tried leaving one and just like not simplified at all.
Oh, all fractored out
Plugged
and
in the
stuff?
whole
Yeah.
implicit, and it was like, that's good, and then the next problem,
Yeah.
it's like not simplified.
It's not like there's never going to be anything that's perfect. But at least it gives you a little more feedback than doing the problems and not getting them. Okay, let me know when you're ready for the answers to this. And then we're done, and you can work on corrections. And if you have any questions that you want to ask me about corrections, then